right, this is the last one. So you have a regular polygon. Again, I'm just going to use a basic example. All right, what do you have? We are giving you the radius. So think about the center, okay? Now, the radius, technically you have a circle. So this polygon is being inscribed inside a circle. It's a triangle inscribed in a circle. That's the fancy term. So the radius, here you have basically from the center to one of the points on the circle. That's your radius. However, it's also from the center of this equilateral triangle to the vertex, to one of the corners, if you want to say that. All right, so we need to find the central angle. So again, from the previous video you watched, the central angle can be found if you can split this triangle into 3 different parts. Okay, once you split that triangle into 3 different parts, we need one of the central angles. Okay, so we're going to need just this part. All right, so we're going to go ahead and do this central angle C value is equal to 360. Again, going around one full circle, that's 360 degrees divided by number of sides. So here we have a triangle, so it has 3 sides. Again, I'm going to write it down, n equals 3. So this come out to be 120 degrees. All right. Now we need half of the central angle, so we're going to cut it in half. Why are we doing that? Well, technically this segment right here is your apothem, which we'll need it to find the area later. So we're going to cut that triangle in half and cut the central angle in half as well. So if the whole thing is 120 degrees, what is half of 120? So if you're following along, h has the value of 120 divided by 2. Again, if you're thinking, then that's half of 120, which is 60 degrees. All right, now we're going to get into cosine, or trig function in this case. So think about our right triangle, okay? Given the angle up here is 60 degrees, you do know the radius, so all radii will have the same value. So if this one is, I didn't give you a number, so I'm going to give you a number. Let's say this is 8, okay? So these radii will have the same value, 8, okay? So that means the hypotenuse of this right triangle has the value of 8. All right, so why are we using cosine? Well, to find the apothem, which is right here, okay? The apothem is the adjacent leg. Adjacent mean next to. So the adjacent leg of this 60 degrees angle over hypotenuse. Again, I'm going to rewrite that for you. So, I know, right? So and so katoa. So opposite over hypotenuse is sine. Adjacent over hypotenuse is cosine. And tangent is opposite over opposite over adjacent. All right, so why are we using cosine again? Because we only have the adjacent leg and the hypotenuse. All right, so adjacent over hypotenuse, we're going to use cosine.
This is a reminder that the building will be closing.
Paused.
All students must be checked into an after-school activity.
All right, sorry for the interruption. Again, we are going to use cosine because it's the adjacent leg that we are looking to find, and then the hypotenuse, which is given. So I'm going to go ahead and do cosine of 60 equals adjacent, which is A, also the apothem, and then over hypotenuse, which is 8. To solve, you're going to basically get rid of this divided by 8 by multiplied by 8. So we're going to do that to both sides. And we get, let's see, A equals let's see, if I use scientific calculator, cosine of 60 times 8, A equals 4. Okay, so our apothem, which is also our adjacent leg, has the value of 4. Now we can go ahead and move on to use sine to find half a side length. All right, so if we know A, we can use, this is 4. Technically, we could also use the special right triangle here as well. So if you don't want to use special right triangle, then you're going to have to use, let's call this, what did we use? I think this would be D, right? All right, so we're going to do, okay, sine of 60, which is opposite, which is D, over hypotenuse, 8. All right, so again, we're just going to multiply 8 to both sides to get rid of 8 on this side, and we have D by itself. So let's see what we get. So sine of 60 times 8, 6.928. So we're going to leave it at that for now, and then we're just going to keep going. Find a side length. So side S equals 2 times D. So again, if one side of this part is 6.928, we need 2 of them. So you can multiply by 2. So what is, let's say, S going to be? S equals 6.928 times 2 equals around 13.856. I'll keep it at that. And then we need to find perimeter. So our next step would be to find the perimeter. So here we have one side length. Perimeter will be using number of sides, so n times the side length. Okay, so number of sides. Our triangle has 3 sides, so we'll do 3 times 13.856. Keep it the same color, except the side length. Here we have times 3, so our perimeter is around 41.569. Now we can find the area. So area I'm going to put over here, step number 7, equals 1/2 times the apothem times perimeter. So if I substitute A for 4 for A, and then P 41.569, I get area equals, I'm going to do 4 times 41.569 and then divided by 2. So approximately 83.138. So area of this triangle is roughly about 83.138.